Everyone, welcome to this video. This is lecture number 65. Already 64 lecture completed and covered the solution of the supplementary problem of the book Vector Analysis by M.R.Spiegel. You know this book is very important for physics as well as for mathematics on us and also important for IIT JAM examination. That's why we decide to solve the supplementary problem of this book. In this video, we want to solve the supplementary problem 6.66 to 6.70 of chapter 6, which consists divergence, Stokes and related integral theorem, mainly Green's theorem. So let's start with question 6.66, which says the let A is a vector. Evaluate the surface integral over the surface intersect of cylinders x square plus y square equal to a square and x square plus z square equal to a square. Okay, so if I want to draw the surface of these two, x square, this is taken x, this is taken as y, and this is taken as z. X square plus y square equal to a square, that means the circle will be like that. X square plus y square equal to x square plus y equal to x square, that is like that. This is a circle, and along this direction this is a cylinder like that. Okay, and another one is x square plus z square equals to a square. That's mean another one is x square plus z square, x square plus z square equals to 1. That's mean like that. Okay, so this is the x square plus z square is like that. That's mean this will be like intersecting, they intersect each other. Okay, so if you want to draw the intersect point, like in the xy plane, there is a, in the xy plane, in the xy plane there is a this x square, in the xz plane also this one. Okay, and the these two are plane surface and other surface is like that. In this is covered and they intersect like that. Okay, I want to integrate along that. Taken this surface is 1, this is 2, and another one is 3. So at first we need to calculate the curl of A. So what is the value of curl of A? Curl of A, this is nothing but I cap, j cap, k cap, del del x, del del y, del del z, right? And a vector coefficient I cap is 2yz, this is minus x plus 3y minus 2, and this is x square plus z. So I cap del del y of this is 0, del del z of this is also 0, plus j cap del del z of this is 2y, and del del I del del x of this is 2x, plus k cap del del x of this minus 1, del del y of this is minus 2z. So this becomes 2y minus x j cap, and this is minus 1 plus 2z k cap. This is the curl of A. This is the curl of A. Now we need to dot this curl of A with the n cap. So for surface 1, for surface 1, the n cap is nothing but minus j cap. For this surface, this is the n cap, which is nothing but minus j cap. So this is minus j cap. So if you want to dot this curl of A with this n cap, we will get the, if you dot with j cap, so this will be minus 2 y minus x. We got this value. Now if we want to find the this integration, that is the integration curl of A dot n cap into ds, right? So we got this value. This value is nothing but minus 2 y minus x. This value is nothing but minus 2 y minus x, and dx dy in this plane, dx dy is the dx dz, dx dz, and this is n cap dot j cap, this is 1. And in this plane, you know, in this plane y is 0, so if you put the value of y is 0, you got the plus 2x dx dz, right, dx dz. And the z value of this equation changes from x to a, since the equation x square plus z square equal to a square, x square plus z square equal to a square, so z is changed up to root under a square minus x square. So if you integrate with respect to z, you will go z and limit will be 0 to root under a square minus x square, and this is dx, and there is 2x, right. So we put this value, that is 2x root under a square minus x square dx, and the limit will be limit of the x will be 0 to a. Just put the value 0 to a of the limit x. So you got the relation, if you put x square minus x square equal to sum t square, so minus x dx equal to t dt, and if we put the value x and t, if we put 0, this will be a, and this is a, this is 0, so minus, this is 0 to a to 0, and 2x, that is t dt, and there is t, so this will be t cube by 3, and this minus will be plus minus, and 0 minus a cube by 3, that is, there is a missing, there is a 2, there is a missing of 2 there is a missing of 2, that is 2/3 aq. Okay, so the value of this integral will be 2/3 aq. I think there is a mistake, plus, no, it's okay, it's okay. Hmm. Hmm. Okay, next, if we want to find out the integral in this region, the n cap will be minus k cap, n cap will be minus k cap in this region, n cap for region 2, for region 2, for region 2, n cap will be minus k cap. So if we dot with this vector minus here, that is 1 plus 2z, this becomes 1 plus 2z, that is curl of a dot n cap, this will be 1 plus 2z, 1 plus 2z. Okay, so if you integrate in this plane, it will be, in this plane the element will be dx dy, so dx 1 plus 2z dx dy, and you can say z value on this plane will be 0, so this becomes dx dy, and the limit of the y will be 0 to root under a square minus x square, because the equation of this circle will be x square plus y square is equal to a square, x square plus y square is a square, right. So from that we can see this is the limit of y, and this becomes s, so this is root under a square minus x square dx, this is 0 to a. So if you put the value of this integration, this will give you x by 2 root under a square minus x square plus a square by 2 sine inverse x by a, and the limit will be 0 to a. If you put the value a, this will be 0, if you put the value 0, this will be 0, so in both cases this term will be 0. In the term, this is sine inverse 1, that is pi by 2, so this become pi square by 4. Okay, this is become pi square by 4. This is clear. Okay, okay, this is the value. So you can see that the total integration of these two surface will be pi square by 4 plus 2/3 AQ. Okay, 2/3 AQ. 2/3 AQ. Actually, this was given in the solution with a minus sign. In the another surface was this complicated surface. I do this, but I didn't get this solution. That's why I want to say, if you can do this, please comment in the comment box or send me in my WhatsApp number of the solution. I want to go through the next question. Next question is says a vector b vector is always normal to a closed surface S. That means this is a surface S and the b vector along to the normal of this surface, so that this integral will be 0. For that you need to know about the formula which are given in the M.R.Spiegel book. The formula says that volume integral of curl of a vector into dv, this is nothing but surface integral of n cross a vector ds. So if you put this relation, using this relation in the our given formula, that is curl of b is this dv, that is nothing but the surface integral n cross b vector ds, just using this formula. Now what is the direction of n cap? N cap is perpendicular to S, so n cap and b cap in the same direction. Since these two are parallel, so you can say this is 0, so total is 0. Since n cap parallel to b cap, that is n cap cross b cap equals to 0, so this integral will be 0. Go to the next question. Let this integration then prove that this. So that what that you need to know, the you need to just apply the Stokes theorem. Just apply Stokes theorem. Stokes theorem says that a cycle integral of any vector control loop, that is circular integration of a closed loop, is equivalent to surface integral of curl of a vector into ds. This is the Stokes theorem. So just using this, so here E vector is a vector, so this is curl of E vector dot ds vector, integration, surface integration with minus 1 by c del t of surface integral integration h dot ds. So if we want to write this as a minus 1 by c del h del t, that into ds. So if you compare in the both side, you can say that curl of E is nothing but minus 1 by c del h del t. Hence proved. Okay. Go to the next question. Prove phi dr is equal to that. For that you need to know the identities, that is called, that is dr. This is any operator, this can be cross, this can be dot, this can be cross, or any multiplication, simply multiplication, right? So this operator into psi equals to surface integral n cross grad this operator psi ds, or integration, these two can be written as ds vector into cos psi, right? So if you use this formula here, the operator taken as simply multiplication, this is taken as simply multiplication, this taken as simply multiplication. So you can say this phi dr is nothing but surface integration ds cross curl, and this is simply multiplication, this is psi. So this can be written as operator operate on this, this is nothing but grad phi. There is not psi, this is will be phi, just apply this. So this will give the proof of this question. Go to the next question. 6.70. Use the operator equivalence solved in the problem 6.25. In the problem 6.25, the operator was given in is that the del with that operator is nothing but or equivalent to limit delta v tends to 0 1 by delta v surface closed surface integration of ds into that operator. This is the formula or the notation of the this operator with the del operator with this any operator. This can be dot cross or simply multiplication, okay. For that you need to calculate this in rectangular coordinate. So at first this, so this taken as the phi, this taken as simply multiplication, delta v tends to 0, that is 1 by delta v surface integral into psi. This is the simply multiplication, right? So this can be written as delta x, delta y, delta z, and this is nothing but I cap, then this is y dy dz, j cap, actually this would be delta y, delta z, j cap, delta z, delta x, k cap, delta x, delta y, and this is the psi. So in case of I cap, you can see the delta y, delta z, only delta x, so this can be written as del psi, del x. In case of j cap, you can see they are two are eliminated, only y is present, so you can say that k cap del psi del z. Okay, so this can be written as del psi del z. This is the proof of the, or the, you can see in that grad phi in the Cartesian coordinate, this is the formula. If you take that is as a dot, that is a vector, that is this take as the dot, okay. So this will be become delta tends to 0 1 by delta v surface integration ds dot a vector. So this can be written as delta v tends to 0 1 by delta x, delta y, delta z, and this is nothing but I cap delta y, delta z, delta z, delta x, delta y dot a vector is nothing but I cap ax, j cap ay, k cap az. So if you dot I dot I is 1, so you can say this is nothing but 1 by limit delta v tends to 0 1 by delta x, delta y, delta z, and within integration this will gives you that is ax, delta y, delta z, ay, delta z, delta x, and that is az, delta x, delta y. So you can see this will be nothing but del ax, del x, del ay, del y, and del az, del z. So this is nothing but divergence of A in the Cartesian coordinate system. Number C, which will be the curl of A. So curl of A, that is this vector, this is called, URL actually cross this tag as cross product. So you can see limit delta v tends to 0 1 by delta v surface integration of ds dot ds cross this vector. Okay, so this can be written as limit delta v tends to 0 1 by delta v. This is nothing but if you take into the limit, this is nothing but I cap delta y delta z j cap delta z delta x plus k cap delta x delta y cross a vector. So limit delta v tends to 0, and so if you take this limit, you can see they are only this can be written as delta x delta y delta z. So you can see this is I cap del del x plus j cap del del y plus k cap del del z cross a vector. A vector is nothing but I cap ax plus j cap ay plus k cap az. Just cross product these two, you can get a cap j cap k cap. This is nothing but del del x del del y del del z, and this is ax ay az. Okay, this is the curl of any vector in the Cartesian coordinate. Okay, that's it. This is all about me. This is my contact details. You can contact with me by the WhatsApp number regarding any physics related question, and this is my YouTube channel details. Go to this channel, you get all the videos which already uploaded, and share this video to your friends so that he or she also get benefit from this video. Subscribe this channel if you new in this channel, and press the bell icon to get the notification of upcoming video related to physics and as well as for mathematics. Thank you, take care, we will meet in the next video as soon as possible.